Imagine cramming the surface area of a football field into a shot glass. If such an expansive surface area in such a small package could trap deadly toxins, you'd have one powerful defense against hazardous waste spills, perhaps even against chemical attacks. Well, that's the concept behind FastAct, a family of products recently created by Kansas-based Nanoscale Materials Incorporated to capture and neutralize corrosive acids, toxic industrial chemicals, even chemical warfare agents. FastAct is composed of harmless, naturally occurring minerals made from magnesium, titanium, and oxygen. For several decades, researchers have known that these minerals can absorb and break down toxins, but there was no way to make the compound efficiently and in large quantities.
With the support of the National Science Foundation, Nanoscale developed a method to produce vast quantities of FastAct by using nanoengineering, or engineering at the scale of dozens of atoms. The new material is not only cheaper than the laboratory version, it's more uniform, more predictable, and even more effective.
The critical properties, surface area and reactivity, enable emergency teams to quickly and effectively counter virtually any liquid spill or vapor release, even if the responders don't know which toxic chemical they face. Many hazardous chemical treatments only absorb toxic substances, which can later detach and be re-released. In contrast, for many toxic chemicals, FastAct encapsulates, neutralizes, and destroys the deadly substances quickly. In tests by the U.S. Army and Battelle Memorial Institute, FastAct removed chemical warfare agents from surfaces in less than 90 seconds, then went on to destroy them, forming much safer byproducts. When a scoop of FastAct mixes with liquid containing parathion, a common toxic insecticide, the normally white FastAct powder turns yellow, indicating not only absorption, but breakdown of the parathion into other chemicals. The toxin is destroyed. Gas chromatography, a technique used to determine the chemical components of a mixture, reveals how much parathion the treatment removed. In this test, 3 samples are run. The results? Parathion in a solvent without any treatment. After treatment with the absorbent emergency responders most commonly use. After treatment with FastAct. The common absorbent was not effective at removing parathion from the solution, while FastAct removed and destroyed all of it. In his laboratory at Kansas State University, Nanoscale founder Dr. Kenneth Klabundy was first to develop the techniques that ultimately led to FastAct. Support from NSF's Small Business Innovation Research Program helped Nanoscale create the manufacturing processes that allow commercial-scale production.
The technology is extremely innovative and may prove to be critical during emergencies.
Nanoscale is currently working with a number of emergency response officials nationwide to provide a safe solution in the event of a toxic chemical release. The company envisions its FastAct units becoming as common as fire extinguishers in airports, subways, and other public facilities, where an immediate response to a release may mean the difference between hazard and catastrophe.
FastAct is a revolutionary chemical hazard containment and neutralization system effective against a broad range of toxic chemicals with the added capability to destroy chemical warfare agents. The technology behind FastAct was originally developed in conjunction with the United States military and targeted the destruction of chemical warfare agents. Building on this technology, Nanoscale's researchers expanded the product's utility to contain and neutralize a wide range of commonly encountered toxic chemicals in addition to the destruction of chemical warfare agents. FastAct enables users to immediately respond to liquid and vapor hazards utilizing a single product for any situation. FastAct works quickly to reduce chemical hazards including acids. FastAct is capable of neutralizing all acids, including hydrofluoric, to safe pH levels without over-neutralization. Toxic vapors. Aerosolized FastAct can remove toxic vapors such as acidic and caustic gases from confined airspaces. Phosphorus and sulfur compounds. FastAct reacts to form less toxic or non-toxic byproducts of these highly dangerous chemicals. Organic solvents. FastAct safely contains liquid spills and provides simplified cleanup. Industrial solvents. FastAct can absorb and neutralize many commonly utilized solvents. chemical warfare agents. FastAct's effectiveness has been verified against GD, VX, and HD by independent laboratories, including Battelle and SBC-Com. FastAct's innovative chemistry quickly contains and chemically binds hazards, providing an immediate response to eliminate the threat. An operator maintaining equipment encounters an unexpected problem. A line begins to leak. The operator grabs a bulk pail and begins to apply FastAct around the spill to immediately contain the spread and neutralize potential threats. FastAct bulk pails are ideal for immediate safety response to spill containment and neutralization applications. A container of corrosive liquid is accidentally knocked off a ledge. Litmus paper confirms the corrosiveness of the spill. The litmus paper turns to bright red, indicating the substance is highly corrosive with a pH of around 1. FastAct is applied to the spill with a shaker bottle. The residue is sampled and the pH is tested. The litmus paper turns green, indicating that the corrosive liquid has been neutralized and can be safely disposed. FastAct shaker bottles are ideal for a wide variety of small spills and immediate safety response applications. For this demonstration, a technician wearing the appropriate personal protective equipment for hazardous vapors prepares to flood a chamber with anhydrous ammonia. The gas is released from a lecture bottle. Draeger tubes are utilized for agent detection. The color change from yellow to dark blue confirms the presence of anhydrous ammonia in the chamber. A FastAct pressurized cylinder is used to neutralize the vapor hazard. The safety pin is pulled and the powder is discharged into the airspace. The FastAct formulation is easily airborne and remains suspended for minutes. A second reading is taken with a Draeger tube. The tube remains yellow in color, indicating that FastAct has successfully removed the vapor hazard from the room. FastAct pressurized cylinders are ideal for hazardous vapor releases and immediate safety response applications. FastAct is easy to use and requires no special training. FastAct delivers a safe, non-toxic, non-corrosive, and non-flammable dry powder formulation that is effective over a wide range of operational conditions. All FastAct units are portable and ready to use immediately to respond to hazardous spill or vapor releases. A variety of accessories are available to complement the FastAct system. FastAct provides safety benefits beyond traditional measures. The broad range of utility makes FastAct a valuable tool for a variety of environments, including public and commercial transportation, government facilities, laboratories, production facilities, shopping and entertainment venues, police, fire, and other emergency response, healthcare facilities, any place where hazardous chemicals are a potential threat. FastAct, first applied sorbent treatment against chemicals.